Hey, how's it going, everyone? Just want to do a video on a little bit of follow-up on the non sequitur debate yesterday. I just wanted to kind of go into this a little bit more detail, clarify what I was trying to get across, which I don't think did. But, I just opened this up to the general community. Looks like there's a lot of very, very smart people on the BALLER side and very eager, to defend their faith. So here it is. Here's your chance. So I'm going to have to use this sort of mock-up, but it's, very, very practical, very real, very obvious to reproduce and all that. But for now, I'll just use shapes and stuff that make the math a little bit easier. But let's imagine we have this big, U-shaped object. It's, suspended, stuck to this ball earth. And let's assume it's very, very heavy. So it has a field operating on it, but let's focus on the one vector that's coming out from its center of mass, perpendicular to the Earth's surface towards the center of the Earth. And the strength of that vector is governed by the formula that everybody knows, G m1 m2 over, in this case, r squared. And so it's sitting on the surface of the Earth. And let's assume, like I said, it's very heavy, and magnitude is governed by that formula. Now let's assume we have another same shaped item, smaller, more fragile, lighter. It has its, same, vector. Let's assume that it is small enough that it could sit under the first item, but, same rules apply as the previous case. It's vector perpendicular to the surface going towards the Earth's core. So now let's combine these two items. So now we have the red U-shaped ring on top of the yellow one. Now the thing is that these gravity vectors are indeed collinear, but the thing that we need to explain, because we know in real life that assuming that the red shaped item is rigid and structurally sound and it's not collapsing, it will not crush or destroy the inner item that's fragile. We know that. It's common sense. So now we have to understand, why doesn't the red object's gravity vector crush the yellow object? They're collinear. They're literally occupying the same space. This force, if it's real, and is acting on these objects, obviously it's invisible, but the forces are acting in the same place in three-dimensional space. One would think that they would interact. So we know that in real life that the red item would not crush the yellow thing. So we need to understand why these two gravity vectors are able to not interfere, and understand it mathematically, most importantly. So just to review the assumptions that I made, we have one heavy object as a high and it has a high amplitude field acting on it at its center of mass, which in this case is not actually on the U-shaped ring, which might be an issue that I might discuss in the future, but let's just go with it. That's the way that I was told that the gravity vector would act. It's on the center of mass of the object. One lighter object has a low amplitude field acting on it at its center of mass towards the center of the ball Earth. So the two center of masses are perfectly aligned. Therefore, at least one gravity vector is collinear, which is emanating out from the center of mass of both objects. So we know it's a field, but let's just zero in on those two vectors for now. We can apply this understanding or lack of understanding to the other vectors. Let's assume the vector strengths are governed again by that formula. So nothing I've said or done up to this point should cause a BALLER any problems. If there's anything that they don't think is correct here in this setup, everything I said is consistent with reality, that you could construct this, have those two things sitting on top of each other and not destroy one another. And then this is the sort of mathematical framework for the gravity vector field. So I haven't violated anything. So now I leave it to BALLERs, actually. So they have a responsibility to explain why those two perfectly collinear vectors do not interfere. So we do know that if they do interfere, that they would add together because the gravity vector field obeys the law of superposition, which holds for linear systems. This is according to, I called him Deacon George, but George H. on the call last night. So if they add, why isn't the inner object experiencing the summation of the forces? This is ultimately, what I'm getting at, is that yellow item has a vector, has a gravitational vector associated with it, and then there's a red item sitting on top of it that has a gravitational vector as well, and both of those vectors are occupying the same space. That vector, the strength of that is acting in the same space for the red one and the yellow one. So now the question is, if they don't interfere, which we know that they don't, in the sense that we know that red item is not going to crush the yellow item. So the force that is emanating from the red U-shaped ring is not interfering with the yellow one, because if it did, it would actually crush it. So if they don't interfere, which is kind of rhetorical because they don't, explain mathematically how these collinear vectors are somehow non-additive, or a better term is they'd have to be mathematically orthogonal. And I mentioned what orthogonality is. It's a term that's used in math to explain that you basically have one signal or one vector in a subspace that's independent of another one. So this is what I want explained visually. I want the Good Will Hunting, the Matt Damon, to come up and stand up, and explain this to me. This is a major flaw. This is the first thing out of a flat earther's mouth usually is this qualm, this issue that we take up with gravity. How is that possible? How can gravity hold large bodies of water, but it manages to not crush or destroy like the animals that are the fishes and stuff in the sea? How is that possible? And so this is your time to shine. This is I was on the call yesterday, and a lot of trolls. I don't know if they're trolls. From the way that they were typing, they're scholars, so I look forward to hearing their scholarly replies on this. So these are some options. I really think these are the only options. So ballers will just have to say they don't know how this works mathematically, which is fine, but to me, they have to calm down with this whole we love math routine. When the field allowing the ball earth to exist, the gravitational vector field, cannot be understood or characterized mathematically. That's a big problem. That's a major problem. This ball earth model, the only way a ball can exist is if a force called gravity allows items to apparently independently stick to the ball. And if that cannot be understood mathematically, that's a major weakness. That's a big problem, especially with how gung-ho the group appears to be about math, but let's see how much math they actually produce. So they can just say it just works, and then which requires faith, and then effectively becomes a religion. In my opinion, obviously gravity is not a real force. It is the magic needed to have items independently stick to a ball, cling to a ball. So I'm going to have to put some rules up, because I got a lot of trolls, a lot of geniuses in the comment section. So I have no problem interacting with geniuses. I'm not one. I tell people this regularly about my experience at Rice, that the best student in our first year grad program was actually an undergrad who did his PhD at MIT and is now a professor at Caltech. So I have no issues being around smart people, letting them know that they're smart, reminding them regularly they're much smarter than me. I have no issues with that. That's and it's like I also use the analogy in golf. I only like playing with golfers who are at least as good as me, if not better, so I can get better. So I just want the same thing here. I don't want people, and not to be rude, who are dumb or not as intelligent as me, or not thinking about this clearly or want to articulate this mathematically. I don't need to hear from you on this video. This is not for you. But if it is, first state your academic and or professional background, degrees, certifications, links to verify this, like LinkedIn, etc. And you can seek clarification or answer my question posed with mathematics. No emotions, no ranting, no actual equations or how I can form the equations myself. Don't send me PDF links with like 50 pages of mathematics on random things. Like this is a very specific question. If it has not been addressed in the theoretical community yet, which would be incredibly insane if it has not. But if it has, you can send me something, but it has to be very specific, and I need to make sure you yourself understand it. And I'm not going to read the thing and then learn it on my own. I'm going to see, do you actually understand it? You can put it there and say, I don't understand it, but the answer is here, or at least I think the answer is here. That comment might survive, but I'm going to be very strict about what I let go on this, just because I want this video to be instructive, where someone could come back, watch the video, see whether it's answered or not, how, and it's sort of like its own little resource, and no emotional rants and all that kind of stuff, which I'm getting. So we'll keep this mathematical and analytical, and just as a reminder, in my opinion, the Earth is obviously observably and provably flat.